Let's talk about the layout of the periodic table. Now, this is what the periodic table looks like. This particular table has no atomic numbers or atomic masses or symbols. This is just the general shape of the periodic table. Now, on the left side of the periodic table, that is everything that you see in yellow here, those represent the metals in the table. They're conductors. They typically lose electrons when they bond, which means they tend to have a positive charge as an ion. And so we call them cations when they're charged. They tend to be malleable, which means you can hammer them out into a sheet, like aluminum foil. And they tend to be ductile, which means you can draw them out into a wire, just like copper. On the right side of the table, in the light yellow, are the nonmetals. They tend to be brittle. They tend to gain electrons, so they will have a negative charge when they are in their ion form, and we call those ions anions. So anions are ions which have a negative charge, and they tend to form mainly covalent bonds, but they will bond ionically with a metal. Now, we can take a look at these specific elements that seem to be kind of between the metals and the nonmetals. These are referred to as the metalloids. They have metallic-like properties. They also possess some non-metallic properties as well. On your periodic table, you have a red staircase going down the table in this general area. Any element that has a full side touching that red staircase would be considered a metalloid. Now, within the periodic table, the vertical columns are referred to as groups. This first group in the periodic table, those are called the alkali metals. Alkali metals tend to be highly, highly reactive metals. The second group in the periodic table, the light yellow here, this is the alkaline earth metal group. They tend to be fairly reactive, but not quite as reactive as the alkali metals, and they form basic solutions. That is, they form solutions that have a pH generally greater than 7, and they are, from the name you can tell, they are found within the Earth's surface and crust. The next group of elements are the halogens. The halogens tend to gain electrons, and they'll have a -1 charge when they're in a bond. They tend to make up your halogenated light bulbs. The next group is this big group in the center. These are the transition metals. Transition metals tend to be highly colored, so copper forms blue solutions, and nickel forms green solutions, and manganese can form purple solutions. So they tend to be very, very colorful when they're in solution. They tend to lose electrons to bond, and when they lose electrons, they tend to take on a variety of charges, which we will talk about when we get to the transition metal naming. This next group, they are the noble gases. That's the end group. Noble gases tend to generally not react, although a couple of them will react, so they're fairly inert substances. This group that you see at the bottom that's very lightly colored yellow, those are the inner transition metals. They tend to contain a lot of synthetic elements. They tend to contain a lot of radioactive elements. We tend not to deal with the inner transition metals very often. Now, our modern view of the atom is that it's mostly empty space. There are two regions of the atom: the nucleus, which contains the protons and neutrons and has a positive charge and is extremely dense, and then the electron cloud, where the electrons reside, which tends to make up the greatest volume of the atom, tends not to be terribly dense, and it generally takes on a negative charge. Now, there's a few terms that we need to be aware of. First of all, the atomic number, and you will see this on your periodic table. The variable that stands in for atomic number is generally Z, and it's the number of protons within the nucleus, and it determines what that particular element is. Okay, and you'll see the atomic numbers on your periodic table. A is the symbol for mass number. Mass number is the number of protons plus the number of neutrons. Now, certain elements will have atoms within their sample that has a different mass number because it's either got more or less neutrons. These particular atoms are called isotopes. Isotopes are atoms of the same element with a different number of neutrons, so they have a different mass number. They will still have the same atomic number, and if they're neutral, the number of protons that they contain will equal the number of electrons. And again, this is if the particular element is neutral. Here's a general symbol for an isotope. X is the symbol, A is the mass number, Z is the atomic number. And notice for sodium there, that's 23. I know it says 2 above a 3, but that's a 23. And that's the mass number for this particular isotope of sodium. And then the number at the bottom, the 11 there, that is the atomic number, which for sodium, that particular atomic number never changes. So this gives you a little bit of an idea about the layout of the periodic table and a couple of the terms associated with the table.